All right. I think it's recording. All right. Yep. It's recording now.
Okay, so I was confused on some of the questions. Let me pull them up. I was working on them right now. I was on chapter 5, and it was like, hold on. It was something about, okay, so it's something about after you standardize the scores, how do you calculate the stuff? It's okay, it was the question was a distribution with mean of 61 and standard deviation of 6 has been standardized to reflect a new mean of 50 and a standard deviation of 10. What is the new standardized score for a score of 52 in the original distribution? So I really didn't know how to do that one, and I was confused.
Did you get a chance to take a look at in the textbook on how?
Yeah, but I didn't really see. I read the textbook and I took notes, but I was able to answer the rest of the questions fine. It was just that one topic that I was a little confused on.
Yeah. Okay. Let's take a look. I have to go to the text real quick. So let me open it up real fast. Hold on, let me let my dogs in. Hang tight. They're being silly. They're so silly. Okay, all right. And while that's loading, okay, so you're in chapter 5?
Mm-hmm.
Okay. And you're looking at
how scores change after something is standardized.
Right. And the textbook, full book. Not letting me do that. What number was it?
It was, I think, 15. I want to say 15. Not 15. 16. Is it 16? Yeah, 16.
16. Okay. A distribution with a mu equal to 61.
Mm-hmm.
You want to reflect. Reflect a new mean. Okay.
Hello.
Hello.
Oh, hold on. Yes?
Yes. Hi. I'm ConferZoom.
Did you guys start at 6?
Well, actually, students started coming online at 6. I've been in and out. I was on the phone with my son, and so I was checking the website to see if people were coming in, and every time I checked, no one was there. And then when
what time did it start again, Professor? I'm sorry.
But that's okay. No worries. Let me just. I need to print this out real quick. Just give me a second. There we go. There it is. I just need to be able to see the actual problem. Okay. Okay.
Which one are we doing?
Chapter 5, number 16.
On Monta?
Yeah.
Oh.
Has anyone done that one yet?
On the, like, at the final end or the,
Yeah, number 16. It was number 16. It was one of those where you had to
The new,
the new standard. Yeah, you
Yeah.
basically had the old standardized one set of data, and then you standardized it, and then you had to figure out with the new score what it was in the new data set. So that is actually transforming. Let me see.
Also, real quick,
Yeah, go ahead.
I didn't see. Okay, so when I was reading the textbook for chapter 6, I didn't.
Hold on. You have one question, right?
Oh yeah, sorry.
Let's not jump ahead.
Mhm.
You're on chapter 5, right?
Yeah.
Hang tight. Just hang tight.
Uh-huh. Yeah, I tend to do that.
No. You're okay. Let me go back.
You're not alone.
It's all good. Okay, so if you look at 5.5, right? Transforming z-scores to a distribution with a predetermined mean and standard deviation. Are you in your textbook now?
Oh, yeah.
Yeah?
Mm-hmm.
So did you watch the problem demonstration, the actual video that walks you through how to do that?
Yeah, but I was like, it just kind of like flew over my head. So I just wanted reiteration.
Okay.
Is this the one that the answer says x equals 35?
Yeah.
Okay, yeah, I had trouble too because I didn't find 35 and I went through the problem.
Yeah,
you
same.
through the problem as well?
Yeah, so I'm glad I'm not alone.
Okay, so let me take a look and see. It's been a while since I've done these. There aren't any questions like this in well, actually, it should be pretty easy to do if you know what the z-score location is. Okay, let me go back to the actual problem. Where's my Word document? Okay, so there's a distribution, right? Has been standardized to reflect a new mean of mu equal to 50 and a standard deviation of sigma equal to 10. Right?
Yeah.
Okay. So if I'm looking through the book to see how they actually do this. So if you draw it out, okay, have you drawn it out?
No.
Okay, so so if you look at figure 5.7 in your book.
Okay, I'm in it right now.
Yeah.
Figure 5. Okay, I'm on example 5.10.
Mm-hmm.
Okay, let me go to 5.1. Okay, yeah.
Okay, 5.7. Yeah, example 5.10. It shows you, right, how to draw this out, right? So you look at the first line is the original scores where mu is equal to 57, and there's a standard deviation, a population standard deviation of 14. And then when you transform that data set, right? When you transform that data set, then mu always is, when you transform it into z-scores, mu is always equal to 0 and sigma is always equal to 1, right? And then right below it is the standardized scores where mu is equal to 50 and sigma is equal to 10. So you notice how the zeros, the 57, the 0, and the 50 line up?
Yeah.
Right? And so you can see that in the middle, right, those are your z-scores. So you'll have plus or minus 1 standard deviation, which is one z, where the z is equal to plus or minus 1, and then 2 standard deviations, right, where the z-score is equal to plus or minus 2. Do you see that? Okay. And so you can set up so you can actually see what this looks like, right? You can actually do the same drawing. So you would have to put your mu, the first one would be 61, right? And then you would add and subtract 6, right? And then add and subtract 12, and that would give you the numbers that you need for that first normal curve. Do you see that? Do you understand what I just did?
Yeah. You basically lined them up, and then you added the standard deviations.
You add and subtract, right? Because sigma is the number of deviations, right? So when sigma is 6, that means that
Plus or minus.
Right, it's plus or minus 6 around the mean, right? So on average, the scores are about 6 points away from the mean on average.
Okay.
So if it's 1 standard deviation, then it's plus or minus 6. If it's 2 standard deviations, then it's plus or minus 12.
Yeah.
Right? 3 standard deviations, plus or minus 18. Does everyone understand how I'm getting those numbers? So it's 6 times 1, right?
Yeah.
1 standard deviation, 6 times 1. 2 standard deviations, it's 6 times 2, right? And then 3 standard deviations, it's 6 times 3.
Got it.
Okay.
That was, other than that, personally, chapter 5 was pretty understandable.
Good.
Interesting.
Okay. Just this one threw you for a loop on how to figure it out? Okay. So let's take a look at one of these.
I have to go in 5 minutes, so this will be recorded, right?
What's that?
This will be recorded, right? Because I have to go in 5 minutes, and I'll just watch this later another time once I have to go.
You had another question as well?
Yeah, it's a real quick question.
Okay.
So it's like a yes or no question. So in the textbook, I didn't see the explaining the types of probabilities, but when I was watching your videos and reading through the PowerPoints, I saw you explain it. So we still have to know that, right?
Yes.
Okay. Okay. Wait, that's it.
Yeah. Probabilities. There are probability questions on the lab.
Yeah. That's why I saw this. That's why I was like, oh, how come this is not in the textbook? But it's fine. I watched the video, so I understand it.
What do you mean it's not in the textbook? What's not in? Oh, you mean
like the mutually exclusive and all of that was not explained.
Stuff. Yes, exactly.
Okay.
I added stuff. Yes, that's not in the textbook, and you probably will see some questions on the test about that. Yes.
Okay.
Professor, I have a question. So in module 2, you wanted to do 5, 6, 7.
Right.
And on the Mind tab, it says that chapter 8.
I should have the due date for chapter 8. Someone actually asked me about this. Lindsay asked me about this. So I changed the due date. It should say for the next module. So August, whatever next Tuesday is. So chapter 8 is not on this. You do not have to worry about chapter 8.
Oh, okay.
It's not changed yet? It should. I changed it yesterday.
It changed. I saw it change.
Oh, okay.
Okay, good. Oh, thank goodness.
I didn't look on the change date. I just, of course, I did 5, and then I have to do 6 and 7.
5, 6, and 7. Yeah.
Yeah.
There's 3 chapters this week, so it's a little bit of a break.
Okay.
And then did you post the answers for lab 3?
No. And one of the reasons I'm on the fence about posting the answers because the few labs that I've already looked at for lab number 2, the one that was done last week, some of the answers were copy pasted into the students' labs. And so I want to post the answers, but I don't want students just copying and pasting the answers
getting
from
credit.
What I'm providing onto theirs. You see what I'm saying?
Yeah.
Then it's not helping you in any way, but I also want you to be able to check your answers as well.
Yeah, I had a question on that actually.
Yeah.
So when I was doing my lab, I did my lab and then...
Hang tight, just one quick second. Sorry.
So I did my lab. Like I first did it on a separate Google Doc because I was coming back to it and I didn't want to stay on it. So then when I came back and then I was gonna submit it and then I was checking my answers and then like when I checked my answers for the relative frequency, originally I did it as like decimals.
Yeah, that's what
then,
it was supposed to be.
yeah, and then I checked the answers, and then it was in percentages. So then I was like, oh shoot, I have to transform this into percentages.
No, you don't.
Percentages.
No, the
And then I
percentages
watched
are there. The reason why, well, first, because it's supposed to be in decimals, right?
Oh no.
It is decimals, not percentages.
Yeah, okay, that's what I thought. And then I saw the thing, and then I should have seen the table. It said relative percentage. But yeah, I was just like, oh no, and then I changed all of it. So like now I'm like,
Yeah. Yeah, so relative frequency, yeah, it's supposed to be decimals.
I'm so annoyed at myself now.
It's okay. It's not that big a deal. It's
Mhm.
okay.
Yeah, I can make it up another time.
Yeah.
Do you think,
Oh, yeah.
oh, sorry.
Go ahead.
I should raise my hand.
Go ahead.
Do you think we could do a problem together just to see that we're, that we've done
On the right track?
or we're on the right track?
Yeah. And that problem that for number 16 on MindTap, I don't have any questions like that on the test, and it's not on the lab either. Okay. So what I can do is I can post a really short video afterwards, right? I'll work through a problem so that you can see how it's actually done, right?
Okay.
And then you can have it for future reference. If ever you have to take another statistics class, for those of you who are psych majors, you're going to have to take another statistics class. And if you're not, then you don't have to ever worry about it, but it'll be there for you so that you can just go back and take a look at it. Okay? How's that sound? Is that okay?
Okay, I'll be heading out now. Thank you so much for everything.
Of course, no problem. Thanks for stopping by.
Mm-hmm.
All right. So, what problems do you want? So, what is it that you're having difficulty with other than the?
Well, on lab 3.
Yeah.
So I think what happens is now that we've learned the 3 chapters is the magic words for me to plug in which formula. I think I've confused everything, and that's why I kept emailing you, oh, are you going to be available? Because I really need to
I noticed that you sent me a quick, what time did you get on?
Well, I came now because in your email it said 6 to 7, but then when I went on, it said 5:30 to 6:30.
Oh,
said,
oh my gosh. I totally screwed up. I am so sorry.
No, that's okay.
That's why when you said right now, you're like, yeah, I was coming back in and no one was entering. I was like, wait, didn't it say 6?
Yeah.
No, it's me.
Oh my God.
Oh my God. It is 6 to 7. You guys are right. Hello. Oh my God. I thought it was at 5. Oh my gosh. And I was like on the phone with my son who's in Connecticut because it was going to be too late to call him after 7. And so I'm like, I got to get back. I got to go talk to students.
It's okay. We're here now.
Yeah. No worries. We'll be here. No, we'll be here till 7. It's all good. Sorry about that.
Okay, no, that's
It's just me. I've got a lot of things going on. Okay. So for the lab. So let me go ahead and share my screen like we did last time.
Perfect.
Okay. Yeah.
That's so cool that you could do that.
Yeah, you get to see all my stuff. Okay. So here we go. So here's, so we've got the lab, right? And then what I want to do is probably open up. So do you guys want to, what do you want to do?
Just like on the first one, because
okay.
There's a lot that they're the same, but I'm just afraid that I'm going to confuse things. And I just want to, I love it when I go on your PowerPoint and your explanation is just so soothing and comfortable. So I feel like once we got onto the actual lab, I got all.
Oh no, you got confused. Oh dear. Oh no. All right, I've got to go back into student mode. I forget to do this every time. So let me do that real quick, okay? Before I've got to be in student view. Okay. So lab assignments that are due. All right, let's just go to assignments.
So the formulas that we learned for chapter 1 through 4, it has to be applied to chapter 5, 6, and 7 as well, correct? Or is that
I'm sorry, I didn't catch that.
the formulas that we learned in chapter 4, are those also going to be applied to in this lab 3, or no?
I don't think so. It's only the formulas for chapters 5, 6, and 7.
Okay.
I think those are the only problems. You don't have to you're not having to calculate any standard deviations, not for this test.
Okay.
But it will come back and haunt you.
Yeah, because when I did the exam, I was like taking my time reading, and I was like, okay, I have 2 hours. And then literally, professor, when it came to me like doing in the formulas, I was like, crap, I only have 6 minutes left. So
so my suggestion when it comes to the tests, okay, and especially when there's a lot of multiple choice and then there's calculation problems, do the calculations first.
Okay.
Do those problems first and then go back to the actual multiple choice, right?
Yeah.
Especially like if there's like 1 or 2 calculation problems, like in exam 1, there was one problem that should have been done first and then the multiple choice.
Yeah.
What I noticed is that some students ran out of time. And so I think what happened was too much time was spent on the multiple choice questions and not enough time was left over for the calculation problem, for the actual.
Yeah, because I know I did half of it. I didn't do the whole bar thing, like the little formula table. I didn't do that. I know I did like half of it. Mm-hmm. And I was like, oh God. I was so mad at myself because I only had 6 minutes left. And then it said, like 5 seconds or 10 seconds. And it was like, oh my God, I hurried up and submitted it.
Great. It's like, no.
But at least, I always think of it as like, at least I did half of it and not where it's like completely blank, because it's better to do
right.
half.
Exactly. You'll get points.
Yeah.
You'll get points for whatever you did, right? Mm-hmm. Whatever's been done, whatever work you showed me. And for the correct answers, you'll get points for that. So there is partial credit.
Okay.
So, yeah, you'll be fine. Yeah. All right. So for number 1. So number 1, first thing to do is to take a look at this, right? And to pull out the information that you need, right? And so it's a 2003 study. The Accreditation Council for Grad Medical Education found that medical residents' mean number of hours worked in a week is mu equal to 81 hours. So that is like the first thing that needs to be brought out, right? So let me just highlight that, okay? So that's number 1. And then it's asking you, suppose the number of hours per week by medical residents is approximately normally distributed. So that means it's a bell shape, right? So it's a normal curve, which is important, with a standard deviation of sigma equal to 6.9 hours, okay? So the first thing that I want to ask you is this population data or is this sample data?
This sample?
It's
population, I think.
Okay, so what tells you the symbols, right? You look at the symbols. Are these Greek letters or are these Roman alphabet?
Greek letters.
They're Greek letters. So Greek letters are always what kind of data? Population data, okay? So that's something that no matter what, right, you need to always remember, okay? Greek letters, population data. Roman alphabet, sample data, right? So if this had been M and S, right, we would be dealing with sample data, okay? Number 1. Okay, so we've got this information, and then here, so the first question is, it's asking us, what is the probability that a randomly selected medical resident works less than 70 hours per week? Now, remember that the population mean, right, is equal to 81 degrees. So here, we're looking at a probability that X, right, is less than 70 hours. Right, and this is what we're looking for, is the probability that X is equal to, no, not equal to, but X is less than 70 hours. All right, you don't have to do this part, okay, but this is what we're looking for. All right, In order for us to do that, however, we need to standardize this, right? We need to figure out what the z-score is, right? We need to find the z-score in order for us to look at the z-table to find what that probability is.
So that would be the z equals to...
Yes. So let me go ahead and open up math editor, right? So it's z is equal to...
The fraction,
good.
X minus a
Greek letter, or actually, isn't it here? No, it's not.
It's
No.
on Greek.
It's in Greek letters, yeah. Mu, right?
And then the standard deviation
Is going to be sigma, right? Good. And so there we go. We got it set up, right? So X was 70 minus, what was mu?
It's going to be
81. Oh, wait, I got to do a fraction.
Have to do this fraction.
Let's do the fraction. Let's go back. Okay. No. 70 minus 81 divided by what was sigma?
6.9.
Was it 6.9?
Yeah.
Okay. So it's 70 minus 81 is equal to, and really important, again, fraction. This is a negative number.
Mm-hmm.
70 minus 81, it's a negative number. Negative numbers are extremely important when it comes to z-scores, right? So what does this tell us? Is it going to be below or above the mean?
Below.
Below. Yeah, 70 is below 81, right?
Yeah.
Yeah, so it's got to be a negative number. This is one way to also double check your work, is when you're looking at these numbers, 70 is less than 81, which means it's less than the mean. So the z will always be a negative number. Okay? So this should be, is it 9?
It's 11. Oh, 9. 11.
11 or 9?
11. It's 11. 70.
11. 70 minus 81, 11.
Negative 11? Okay. I can't do those negative numbers in my head. Let me go grab my calculator.
It equals to negative 1.5942.
5942.
Yes.
This is approximately equal to, and we need to round this because in the z table, right? This is it's to do 2 decimal places, right? So this is going to be negative 1.59.
Yes.
Okay.
I have a question.
Yes.
I did this problem. I wasn't sure if I was doing it correct, but when I go to the table, I got kind of stuck. When do I know when it's the body and when it's like the tail?
Ah, that's a great question.
I'm doing it with the tail because it's kind of towards the.
And I don't have. I need. Did you watch my video on this? Because I had videos.
Yes, I was still kind of confused, so I wasn't sure. I went on the.
So this is asking for less than 70. Okay.
Oh yes.
So draw the curve. Okay. Put 81 hours in the middle there. So draw your line, draw the curve, put in the middle 81 hours. To the left of that, put 70.
Yes.
Okay. And then draw a line through that. Okay. Where 70 is.
Yes.
And now it's asking you for less than 70.
Okay. So it's going to be towards the tail.
Tail. Shade it in so that you can see, right?
Okay. So if it was pointing closer to the 81, would that be body?
No.
No, it was still
asking for less. So here's how this works. Here it's asking for something to the left of the mean, right? And it's asking for less than. And this is also true if you're looking for anything greater than the mean and you're looking for something greater than that. So for example, if you're looking for like the next question is asking you about more than 100 hours, right? So that's on the right side of the distribution, right? Okay. That's going to be to the right. It's going to be a positive z-score, right? But you're looking for something higher. So when you draw that out, right, you're gonna do the curve. You're gonna put 81 hours, okay? And then you're gonna draw another line where 100 hours are, and then you're gonna shade in more than. That's also the tail.
Oh, okay. Got it.
When it's the body, okay, if that second part, or let's say the first part here, if we were to say instead of less than 70 hours, if we said works more than 70 hours, notice that your drawing now, it's everything, and it includes the mean.
Oh, okay, I get you.
That's always going to be the body, right?
Okay. Yes.
So the tail is column C, correct?
Yeah, let me go to that real quick.
I believe it's 0.0582 for that one.
Is it?
I think so.
So the probability. So did you look it up?
Yeah, because I was looking at the thing. It's 159.
Yeah.
And then it's column C.
Okay. Good.
159. It's 0.0559.
Is that right? Did everyone catch that? Did everyone get that?
Mm-hmm.
159. Yeah.
Yeah.
0559.
So let me see if I can get to let's see if I can actually get in here.
It's in the module.
Yeah, I know. It's actually up here.
Yeah, you have
in the here. No, this is the formula. You're right. This is the formula sheet. Darn it. Let me see if I can get in here. No, that's not it either. Okay, I need to.
So during the test, we're allowed to have that the Z scores open, correct? As a tab.
Mm-hmm. Access denied. Darn it. Student view.
So, Professor, I have a question. Just because, again, this is somewhat review because I did the 228A, which thank God, because I understand some of it.
Oh,
but
that's awesome.
But is the empirical rule the same? Because again, on chapter 5, I'm doing the PowerPoints because I find it easier, and then I like to look at the videos in the book. Is the empirical rule the same way where it's 68, 95, and 99.7?
Yes.
Okay.
Yeah. Yeah.
Okay.
Yeah, but the empirical rule we talk about, where did I talk about it? I think, don't I talk about it in chapter 6?
Yes, I think it's the second,
second video. I talk about the empirical rule in the probability chapter.
Yeah. Okay, yeah.
Yeah, so I do talk about it. All right, so let's take a look then. 1.59, if you're not sure how to do this, right? 1.59. 1.59, there's the Z. And then it's the proportion in the tail, and there's your probability right here. Okay? Mm-hmm. Cool. Yay. All right, so that's the first one, right?
Yeah.
Okay, so can you figure out the second one?
Yes, you do basically the same thing, except that it's greater than, I believe.
Right, exactly. X is greater than 100, right? That's our probability that we're looking for. And this is actually that. So the first one was that the probability is less than negative 1.59. And so it's the same exact thing, right? That we just did.
Yes.
And this is going to be just over and over again, the same thing that you're going to do. You're going to get tired of doing Z-scores because it's going to be
learning the tricks to it is easier. You can copy and paste it.
Copy paste? Oh, you can? Mm-hmm. Oh, cool. I just want to make sure I show how it's done so that people who are watching it can get the hang of it, right? Okay, so X was 100 minus
81
over
6.9.
0.9. Yep, and then outside equal to 100 minus 81. Oh, fraction. What's that equal to?
19.
Yay, thank you. Divided by 6.9, which is equal to?
2.7536.
What is it?
2.7536.
Which is approximately
2.75.
2.75. Good. All right, third equation. Oh, and by the way, this is what I mean when and then for those who are watching this as a recorded video, this is what I mean when I say show all your work, right? Is show the steps. So that way, if you make some kind of calculation error, I know exactly where you made it, right? So that I can immediately go, okay, when you subtracted the numerator, it's not 19, or when you divided 19 divided by 6.9, that's not 2.75, right? Does that make sense? Hopefully. So P, we're looking for the probability that X is greater than 2.75. Whoop. And we go to the Z table,
I
right?
think it's 0.0030.
Yeah, it's going to be a really tiny number. Yep. 0.003. So the probability here is 0.003. Okay. And you can add the 0 if you want, or you can leave it that way as well. Now, what's interesting here is, remember when I talked about this, I think I talk about this in probability in chapter 6 in my lecture videos. When you have a probability of 0.0559, you know what, it's close to being, it's really close to being something that we would consider to be significant, right? That there is some kind of a difference, but not quite. But with 0.003, that is very different. So the probability that a medical student works more than 100 hours, that is an outlier. That's an extreme value. That is not normal.
Okay.
That doesn't belong. That actually does not belong in this data set where the mean is actually equal to 81 hours. Does that make sense?
Yeah.
Yeah. This is a very low probability. And when we say low probability, it's anything that's less than 0.05, typically in the social sciences, right? That's when we say, yeah, that is extreme. That's not usual, right? And when you look at this, the Z is 2.75. That means that 100 hours is 2 3/4 standard deviations, 2.75 standard deviations away from the mean, right? So that's far, that's way out there in the tail, right?
Okay, cool.
Okay?
And so this is it. You wouldn't need us to write something like you just said.
Not for this particular problem,
Okay.
but I do believe, was there one in here that I asked? Do I ask? No, I'm just having you guys just calculate, it looks like. I'm trying to look to see if there's anything in here where I ask you to explain or interpret. No, these are all calculations. Now for the
I was worried because it was too easy. So I was like, oh no, maybe I'm doing it wrong.
No. But here's the thing though, on the exam, I will ask a question that asks you to interpret. What does this mean, right? So there will be something, if I remember correctly, there's like one of the problems where it asks you, okay, so, you know, is this unusual? Okay, right? So if it's unusual, it's less than 0.05, right? And it'll say, it'll ask like, is this unusual and why, right? And the why that you need to make sure you provide is, okay, it's more than 2 standard deviations away from the mean, and the probability is less than 0.05. That's what makes it an unusual event for this. So if I were to ask this question let's say right here, let's say that part C is this unusual? Why? Why not? Okay. And so your answer here would be yes, right? Yes, this is very unusual. Unusual, right? Let's say the z-score. Oh my goodness, I can't. Y'all are watching me. The z-score is more than 2 standard deviations from the mean, and the probability is very low. You could put like in parentheses p is equal to 0.003 and less than 0.05. And there's your justification for why this is very unusual. Now in this one, right, is this unusual?
No, it's not.
Why or why not? Yeah, you're exactly. No, it is not. Right? And the why?
Because it's more.
Yeah, it's more. It's at 0.5. It's not lower than it. So.
No, it's not exactly. But also the z. Look at the z. Right? Is it more than 2 standard deviations away?
No, it's not.
Right? It's not more than 2 standard deviations
away
from the mean. That's usually kind of the rule of thumb, right? If it's more than 2 standard deviations away from the mean, that's considered to be that is considered to be an outlier or an extreme score or an unusual event. Okay. And the probability is not less than 0.05, right? And there's your justification for why the first one is not an unusual event. Okay?
Because the mean is the 6.9, correct?
The what?
The z-score, is it because it's
the z-score is what tells you whether something is unusual or not.
Okay, so because I was getting confused. I thought the z-score for some reason was 6.9 instead of negative 1.59.
No, it's negative 1.59. Yeah, the 6.9 is the sigma. That's the standard deviation, right? Mm-hmm. The z-score, it tells us the precise location in standard deviation units.
Okay.
That's what's the difference between a standard deviation, right? When you're looking at this standard deviation here, mm-hmm. This is the average distance from the mean that our data are.
Okay.
This tells us the precise location that 70 hours is in terms of standard deviation units.
Okay.
I know this is hard to wrap the brain around. It's like, what? Okay.
Professor, quick question.
Yeah.
Will the answer key for this one be posted up as well after the review, or this one we would have to do it ourselves?
I'm still debating that. And like I said previously, this was asked earlier. I want to provide the answers. However, what's happened with a few of the labs that I've started grading is that some of the labs were copy-pasted my answers onto the answer sheet, onto the student answer sheet, or at least maybe not copy-pasted, but copied in some way. And so it's like, I don't want you guys doing that. I want you to do the work and check your work first.
That's why that's what I was, because I was like, because I'm doing all the work, and I'm like, I don't know if my answer.
Know if it's right or wrong. Yeah, exactly.
Yeah, so that's why I get worried.
If I post it, it's probably going to be sometime tomorrow morning.
Okay, perfect. So it gives me time to double check my answers if I went wrong.
Right. Yeah.
Yeah, because
Exactly.
on one of the on mod on the other one that you told us to do,
Yeah.
me and Alex were staying up till like 3 o'clock in the morning because he was I don't know what I'm doing wrong, and he forgot to add like the frequency and then everything like added up because he was looking at the answer sheet, and I was like, wait, because I was finishing your PowerPoints and I was like, wait, did you do this? He goes, no, I forgot to do this, and then everything added up, and I was like,
Yeah, you get the answer. So it helps to have the key.
Okay, it helps. Okay.
Yeah.
Good.
You see where you go wrong. Like for me, sometimes I don't know what I'm doing, or sometimes I'm like, oh, I don't understand where I'm going wrong, or something is missing. And like she said, like you go back and you try to figure it out until you get that correct answer, and you're like,
Okay.
oh, that's what I'm doing wrong.
Okay. All right. I'll post it. I'll go ahead and post it. Just don't
Thank
copy.
you. Oh no,
Although I think this is going to be a little
don't we
tougher
have
to
to show
copy
our
because
work?
yeah, you have to show
Yeah.
your work, but I have some students who are not showing their work, and so it's really
That-
hard. It's really tough for me to you know to see. Well, yeah, are you just copying, or are you really just doing it all in your head?
yeah.
Uh, which is kind of hard to do. I mean, there are some folks who can do this in their heads.
Yeah.
I know there are people out there who can do that.
Mhm.
I can't.
Yeah.
You really have to write it out, do a calculator, and do it all.
Yeah, that's how it is for me. Like I have to write it out, and then during like the first lab I would write the answers. I was like, crap. I was like, she wants us to show our work. I was like, I don't want you to think that I was like me and Alex were cheating because we would write it
Oh
out
no.
and just type it in. And then I was like, he goes, no, we have to show our work, remember? And I was like, oh yeah. So then it took twice as long because I was like, I have to go to
Yeah.
the
And
page.
this is practice. I mean, the more you do, the more you work with Canvas Editor, the
Mhm.
faster you're going to get, right? You're going to get faster at this. It's going to be quick.
Do you mind if we could do another one together? Something,
No, not at all.
other sets of the formula that we need to plug in.
Okay.
So this way we have at least one example of each that we know we can trust that we're doing. I don't know. These 3 chapters are too, I don't know.
There's only 3 chapters. It's not as many as last time.
I think it's just the information.
It's a lot of information. Yeah. Yeah, it is. It really is. So, what do I want to do next? What do you guys want to do? Well, these are all pretty much the same. I mean, except for like this one here, the top 5%, where it's asking you what score places the child in the top 5% of all children. Do you guys know how to do that one?
I don't know how to do that one, but I haven't got to that chapter yet. So I feel like if I go to the chapter, maybe I'll know.
It's chapter 5.
Oh, okay, well, I'm doing the PowerPoint, so I'm still on the first one where it's the characterization of scores.
The characterization of scores?
Yeah.
Oh, okay. So you're like just starting?
Well, yes and no, because I was helping my sister with my nephew.
Okay.
So I'm doing this, but I do the PowerPoints fast, so I'm
That's
okay.
Fine. No, you're fine. It's all good. Okay. So the first 2 are just what we did for that first problem, right?
Mm-hmm.
Correct. You're going to do it. You're going to do the same, you're going to find the z-score, and then you're going to look for the probability.
Okay.
This one, on the other hand, this one is asking you for the score, okay? So now we're flipping this, right? So now we got to work backwards.
Okay.
So now what we need to do is find the top 5%, right? And that's the probability, 5%, this here. Mm-hmm. This is the probability, which means we need to go to the Z table and find where 0.05, right, what's the corresponding Z-score for 0.05, okay? So we're working backwards. So the probability, right, P here is actually this, right? Probability of X, not X. The probability is, not that X is greater than, no, probability is equal to 0.05, okay? That's what we know.
Okay.
And we also know that that mu, nope, not sure why this, here we go, is equal to 100, and sigma is equal to 15. And these are actually real data, by the way. The Wechsler intelligence scale, the IQ, the population mean is equal to 100, and the population standard deviation is equal to 15. Okay, so these are the numbers that we are going to need to know. And this here, that P is equal to 0.05. And that should be a small p. All right, with me so far?
Yes.
All right, so this is the information that we're pulling out. Okay, now with that P, what we need to do is we need to go to the Z table. And we're looking, the top 5%, is that in the tail or the body?
Body.
That's the tail. Right?
Tail. It's the tail. The top 5%, right? So if you draw the curve, right, Paristu, if you draw the curve, okay, you draw the line and then the curve, okay, your mu is at 100, and we're looking for the probability in the tail of 0.05, the top 5%. Okay?
Oh, okay.
Remember that the area under the curve is always equal to 100%, right?
Okay.
So in the tail, you got 0.05, and in the body, you've got 0.95. Right?
Yeah.
Those two numbers have to add up to 1.
Ah, okay.
Yeah, the area, that's what makes it so, these are fun to work with, because it's like, oh, okay, once you understand the area under the curve, the area is always equal to 1 or 100%, right? If you've got a probability of 0.05 in the tail, then the body has to be 95%, right? So 95 plus 5%, 100%, right?
Mm-hmm.
So in the tail, we need to look for the probability, and remember the proportion is in this area. The first column is the Z, right? Notice how it says A, column A is always Z, okay? Column A is always the Z score. We don't know what the Z score is. We have to determine that based on that probability, based on the probability, which is also called the proportion, okay? So these proportions are your probabilities. So we're looking for 0.05 in the tail. Oh, I went too far. So 0.05, so notice how we're looking in here, Ah, wait, there we go. It's between, notice how these two numbers, right? They're right in there, right?
Yeah.
Okay. So it's 0.0505 or 0.0495. It's exactly in the middle. So the Z for this is actually 1.645, because it's right smack dab in the middle.
Okay.
So the Z is equal to 1.645. Okay.
And then that's all. So are there going to be questions like this on the exam?
There might be.
Okay. So, so when it comes to like us backtracking, would we just have the formula sheet there so we could like look how you just showed us?
Well, the formula sheet is just going to give you the formulas. The way that you look up on the Z table, that you need to practice and get real comfortable using.
Okay.
Okay. Like if I were to say the top 2%, let's say instead of 5%, I had said 2%. Then the probability would be 0.02, and we would have to go here and look for 0.02.
Yeah.
Which is right here. 0.02, 0.202, which is the closest. And so your Z, the corresponding Z, is 2.05.
Okay.
Okay? So you have to work backwards.
Mm-hmm.
You have to, it's not that you're calculating the Z-score, it's you're determining the Z-score based on the probability.
Okay.
So that would be the end? We would just write?
Nope. No, not yet.
We have to plug it in.
Now it's asking you for the score.
Uh-huh.
It's asking for the X value. What's the X value that's your it's your border, right? That separates the top 5% from the rest of the 95% of the children. Okay? So what is that score? So here, and you won't have to do so this one, well, maybe you should. Never mind. Let's go here to Math Editor because it's just easier. So X is equal to mu. Let's go to Greek. Mu. And it's plus Z times sigma. Okay? So this is the formula. And by the way, if you look at the Z formula and you remove the sigma from the denominator, this is basically your formula. Okay? By multiplying both sides, right? With multiplying both sides with sigma, you'll actually come out to this formula. Okay? Does that make sense?
Mm-hmm.
Hopefully. All right. So we know mu is equal to 100 plus our Z was 1.645 times sigma, which is 15. Right? So this is going to be 100 plus, and I don't know what that is, 1.645 times 15.
Is 24.675.
0.675.
Mm-hmm.
So the X value, right? So a child who scores 124.675, or approximately, 124.7, okay, is the child that separates the top 5% and the 95%.
Okay.
So this is X right here. This is your answer. Okay. Whoa, whoops. And that's the intelligence scores that places a child into the top 5%. And anything above that, right? So if it's 125, 126, these children are in the top 5%.
So is this the minimum score?
Yes, this is the minimum score that a child has to score in order for them to be placed in the top 5%.
Okay.
Excellent. Yep, you got it.
Bonus
Well
point.
done. You got it. Yeah. That's exactly right.
The lights.
The lights are coming on. I love it. That is perfect. Awesome. Yay.
Okay. What else?
I think, is that it for those are like the biggies. And then this problem, I did get a question for this one, especially for this last one, where E and F, you're trying to figure out what the probabilities are. These are really straightforward. You don't have to worry about addition rule or anything like that. All of the information are in these little squares or in the rows or columns.
Okay,
right?
so
it's just basically a matter of understanding, okay, the probability somebody has coffee shop experience. So here's E, so it's 62 divided by 105. And whatever that, you have to actually calculate 62 divided by 105 and give me the actual probability, right?
Okay, so do we have to show you like in the
it would be, let me see if I can copy this.
That's 0.59.
Huh?
0.59.
0.59.
So that's the probability that.
Hold on, let's do this.
Write the answer, or do we
Okay.
have to use the?
So for this one, so you would do P. So P of E, right, is equal to 62 divided by 105. And this one's okay if you just this one's okay. I don't mind if you don't use Canvas Editor in here because it's just the two numbers, so it's not that big a deal. It's when you start like doing a ton of work, it's best to do it in the Canvas Editor, and when you're using symbols and all of that good stuff, it's better to do it there. So this is 62 divided by divided by 105, and is
0.59.
0.59.
And it's
even?
It's 59047619.
04. Okay, so that works.
Yeah.
Okay, and then the same thing here. So probability of F, right? Or full time, that this person is actually available full time, and that's up in here. So full time is this row here, and what's the total for full timers?
32.
So 32 out of
105.
105, right? 105. Good.
Here.
Okay. Does that make?
But how come?
And then here, it's going to be just probability of E and F. So somebody has coffee experience and also available. That's just 20 divided by 105.
Okay.
That's it. Because it's the numbers are there, right? E and F. So there's your number, and that's all you need to do. Oh, did you have a question, Kirstu?
Yes, if you can go. So when is it that we use the total versus somebody?
Oh, well, in this case, it's asking you, the probability that someone has shop experience, right?
Oh, of the total.
So it's the total. You're looking at the probability of people who have coffee shop experience versus all of your applicants, right? So same thing. Someone who's available full time, you're looking at, okay, just those people who are available full time divided by the full application pool, right?
Okay, very good. Thank you.
Yep.
And for the answers, you just wanted to leave it there.
Just like this, yeah. Okay. Unless I ask for like a percentage, then you would turn this, if it says what is the percentage, then make sure you turn that into a percent, right? Which would be 59%.
Wow, excellent.
But if it's asking for probability, leave it as a decimal.
Okay, do you want us to round or just leave it the way it is?
Well, it is rounded because the actual number was 0.59004. Or something like that.
That's why I didn't know if you wanted us to round to like their nearest, like instead of 59, 60%.
It's fine, yeah.
We're gonna write the whole number.
And that's fine too. You know what? If not the whole number, because some of them can be really super long. That's gonna take you a long time. So don't do that. But really, I mean, even if it's 59, and if this was, let's say it was another number, it was 0.5914 or something, then it could be 0.5914 or something like that. I mean, it's fine.
Okay. Professor, where do you see something that is going to trip us, or that we're going to be?
This one, for this exam, that's a good question. Typically, most students do really well with this one, especially if they understand like the z-scores and the probabilities. I think the tripping is going to be the probabilities, right? So making sure you know the difference between probabilities and percentages, right? So if it's asking for probabilities, keep it at a probability. If it's asking you for percentage, make sure you put it in a percentage. I don't take, it's not a ton of point. I mean, it's like maybe a point if it's the wrong, if it's not what I'm asking. So what else? Also, what trips up students is knowing when to do the sampling distribution, right? And when to use when to use, what is it? It's standard error, and when to use just sigma, right? So when you've got like this, like number 24, okay, where it's asking you the public school teachers spend an average of mu equal to 443, and there's a population standard deviation sigma equal to 175. We take a random sample of 50 public school teachers who spend more than $400, right, a year. So for these problems here, where you have random samples of 100, random samples of 150, this one is 20, random sample of 20, you have to figure out so it's
sample.
So it's, yeah, you're dealing with a sample, and so it's not the Z formula. Let me show you real quick.
So would this be
we've been using this formula here, right? Which is, it's just sigma, right?
Right.
But whenever we're dealing with random samples, you have to find the standard error. Okay? And standard error is sigma, standard error of the mean, of the sample mean, okay? Standard error of the sample mean. So sigma, right, of sample mean is sigma divided by the square root of n. And that's in your denominator, and that's always what you have to figure out first. And then you can go in and plug it into your Z formula. Okay? That usually will trip students because what ends up happening is they'll read through this problem like this here, where I actually have both. There's one right here. So number 25, it asks you to do both formulas, where the first one, it's saying a randomly selected pregnant woman. So that's one individual. So that's that first formula with just sigma. This second problem here is asking you to find the probability that a random sample of 20 pregnant women have this mean energy need, okay? And so here you'd have to figure out what the standard error is, where it's sigma divided by the square root of n, which is 20, right?
Could you show us, Professor, to make sure that we don't mess it up?
Sure, I can show you. So yeah, so I've already done one with, let me show you a quick one. Let's do this one. So this is a good one, gestation periods.
Okay.
Right? Okay, so the length of human pregnancies is approximately normally distributed with a mean mu equal to 266 days, right? Let me go over here real quick and highlight it. I'm highlighting what you need to know, right? Okay, so sigma is equal to 16 days. The first one, right, it's asking you the probability that a randomly selected pregnancy lasts less than 260 days. So this is just one person, right? Mm-hmm. So it's just one individual. So your formula is the same as it's been, right? Nope. Z is equal to, and this is going to be X minus mu over sigma. Okay? So that's this formula. That's going to be for this one, right?
Okay.
The next problem is asking you what's the probability that a random sample of 25 pregnancies. So the key here is right here. And what this means is n is equal to 25. Okay?
Mm-hmm.
This makes it different than this because this is n equal to 1.
Okay.
Okay? So the formula that you need to reuse here is going to be z equal to, and now because we're using a random sample, we're using the sample mean minus mu divided by the fraction again. And this is going to be sigma divided by the square root of n. Okay? So that's this formula. Now, my suggestion is to actually take this. Let me see if I can actually do this. No, it's not going to let me. Nope. So my suggestion, so this is the actual formula, right?
Mm-hmm.
I'm going to delete it. I would, whoop. I don't know where that came from, but okay. So my suggestion is to actually figure this out first. And this is actually sigma subscript m equal to here, right? So sigma was, what was sigma?
16.
What was it?
16.
16? That was sigma?
It goes by the, yeah.
Yeah, okay. Divided by the square root of 20. Whoop.
Sigma was the 16 day.
Oh no, n was what? I'm sorry. No, n is not 20. N was 25? Thank goodness. Phew. Was 16 days was what?
That was sigma.
Sigma, perfect. Okay. All right, so it's going to be 16, whoops, divided by 5. Thank goodness that round, that doesn't, that's a nice whole number. Right?
Oh, 3.2.
3.2?
Yes.
So that makes it really simple. Okay, so that's part 1, right? And then this would be your first, okay? 3.2. And now you can actually do your z. So that's going to be z equal to sample mean minus population mean divided by your sigma m, or your standard error. Okay? Because you're dealing with instead of dealing, you're no longer dealing with the whole population data. Remember that the population standard deviation, right? When you're using the whole entire set of the population, you can use sigma by itself and figure out what your z-score is. But now what you've done is you've taken out a small subset of the population, right? And so now you're introducing more error, right? You're introducing more error into your analysis, right, by doing that. And so because of that, you need to adjust the sigma, you need to adjust that population standard deviation, right? And it becomes standard error. So far, so good?
Yes.
Yes.
All right. And so now we just plug in the numbers, right? So we know that sigma m is 3.2. We don't have to do that crazy, that crazy fraction in the denominator. I hate doing fractions in the denominator. That's why I always do them outside of the denominator and put them in put in the actual numbers that I've already calculated into the actual formula. So what was sample mean for that problem?
266.
What was it?
166.
366? Is that the population mean or the
No,
sample
that's
mean?
mu.
Oh,
No,
that's
mu is the second number. The first one is the sample mean. So look at the problem.
Oh, is it 16 days?
What is it?
16 days?
Is that
No,
what it says? 60 days?
No,
that's
1616.
16?
that's sigma. That's not.
No,
Oh.
yeah.
I don't have the screen open to see what was the.
Uh-oh.
What's
Yeah, oh, here it is. Hold on. 260 days.
Oh, okay.
Oh,
You see where it says what's the probability that a random sample of n equal to 25, right? Is less than 260 days. So your sample mean here is 260 minus, what was the
266.
mu? 266?
Uh-huh.
Great. Perfect. So then this is going to be equal to negative
Negative 66.
is
Oh,
it,
wait.
Oh, -6, right?
is it? Check.
Yeah.
Negative 6.
Yeah. Did you do the calcs?
Yeah.
Okay. As long as you did the calcs and that's what you came up with. So divided by 3.2, which gives us a negative
1.875.
875. And we need to round that. We need to round that to 2 decimal places, which would be negative 1.88. So we go to the Z table. And remember, yeah, so let me go ahead and insert this. Right? Now that we have this, there we go. And now we're looking for P. So we're looking for the P probability that Z is less than negative 1.88. So is this in the tail or in the body?
Tail?
In the tail. She's like, oh my God, thank God. Yeah, draw it out. This should be drawn out. And I'm pretty sure in my video, I show how to draw these out,
Yes, yes.
right? Draw it out. Put the numbers, right? Put the mean of 266, right? And then draw your curve. And then to the left of that, you're going to put 260 because 260 is less than 266, right? And we're looking for the probability less than that, right? So it's going to be in the tail and it's going to be to the left of the distribution, right? It's going to be in the negative, below the mean.
Below the
Okay? Below the mean. Now remember that probabilities are never negative, right? Your Z's are negative, but probabilities are never negative. Right. All right, so the Z table, we're looking for 1.88 in the tail. In the tail, so there's our probability, 0.0301. And notice how I don't put a 0 in front of that. And the reason you never put a 0 before a probability is because you can't have probabilities that are greater than 1 or less, or greater than 1, right? They're always 1 or below. 1.0, right?
You can't put 0.0301?
No, that would be incorrect.
Oh my goodness.
Don't put a 0 in front of that. Yeah.
Okay.
No zeros in front. Okay.
So can I ask, why last time you wrote a uppercase P and then you put a lowercase p? So
It's supposed to be a lowercase p. P is always lowercase. Yeah. Yeah. That's a good question. It's always a lowercase p. And the reason why, when we start getting into writing out results, it's always a lowercase p.
Okay.
Okay. So I have a question, Professor.
Yeah.
So it would, of course, be good to look at your PowerPoints. And then, of course, it would also be informative to look at your other videos, right?
Yeah, the sample problems. So if you look at, I actually have some stuff in the modules.
Yeah,
I'm
the
pretty sure
module
in this module, I actually work through some problems in the PowerPoints.
Mhm.
So if you look way at the bottom, oh wait, where is it? Here we go, sample problems, right? With z-scores
Mhm.
and probability part 1, and sample problems with z-scores and probability part 2. So I actually walk you through how to do these problems. So hopefully you get a chance to take a look at those.
Also though, the other module, which says module 2, other instructional materials, do you think that we should look at those or just the PowerPoints that the first module?
Well, if you're not understanding or if you want to take a look at these, you can. Sometimes it can be a little more confusing because they use different formulas than what we're using. Okay. So it might be better to just stick to my lectures, the way I'm showing you how to do it. But these are different ways of doing it. So whatever works, whatever helps, try it. Right. Okay. So if it's going to help to do these as well, look at those too. If you run out of time though, I would suggest just looking at the videos here.
Yeah.
Yep.
So the next question asks if it's unusual. Was that the right one?
Yes, and why not?
Okay, so wasn't the big number or the little number 0.05?
Did I think wait a minute. Hold on. I think I added this. I added this in the middle of another question.
Oh, okay.
Yeah, I did. Sorry.
Okay. No worries.
Yeah. This was added. Yeah, I'm like, wait, I didn't ask that in here. Where was it? Hold on.
No, you went right under it. So go.
Right here. Here we go. There we go. There. This is the one. And I needed to go under this one. There we go. There. That's the actual problems. I inserted it in the middle of a question that I had answered previously because I thought I was at the end of the page. So yeah. But I mean, you can totally, is this unusual? Is this an unusual event?
No.
So.
I think it would be.
Would it? Why? Why is this unusual?
Because it's farther away from 1.
Okay, it's farther away from 1. It's not more than 2 standard deviations away. However, what's the probability? Is it less than 0.05?
Yeah.
Yes. Is 0.03 less than 0.05?
Yeah. No, actually, no. I don't know.
Well, so, okay, let's put it this way. Is 5%, or let me see, is 3% less than 5%?
Yes.
Yeah.
Yes.
Okay. So if you need to look at it that way to try to figure out, okay, is this smaller than 0.05? Then that might be a trick to try, right? So is 3% less than 5%? Yeah,
yes.
Absolutely. So is this unusual?
No.
Yes.
Yes.
Oh, it is. Okay.
Yes, but here, and this is why when we say more than 2 standard, because it's confusing, because this is not more than 2 standard deviations away from the mean, right? And that's one of the rule of thumbs that we use, but it's not always the rule of thumb, especially when we're using samples. Once we start using samples, now we start getting into, oh, but it's not less than, it's not more than 2%. I'm sorry, it's not more than 2 standard deviations away from the mean, but the probability is less than 0.05. And this is what tells us whether it's unusual or not. This is more accurate than looking at the standard deviations or the z-score. The p-value is the one that's going to tell you precisely whether or not it is unusual or not. Okay, so yes, and the reason it's unusual,
because it's more than
probability is p equal to, let's say p equal to 0.03, which is less than 0.05. And there it is.
So if
that is how you would say, that's how you would explain this one.
Okay, so I have another question, Professor Purser.
Sure.
If it's always above 0.05, then that's how you know if it's unusual or not, or less than
If
0.05?
it's more than 0.05, it's not unusual.
Okay.
Not an unusual event. And what we mean by unusual event is that this, so basically it's women who have less than 260 days, right, of gestation, right? In this case, because we're dealing with a sample, right, we're dealing with sample data, because of the sample data, this is very unusual, right? Women having less than 260 days for gestation is actually an unusual event. Okay. You guys okay?
Yes.
Like, oh my God, there's so much stuff. We'll do this again tomorrow at 10:30. Okay. And then if you want to meet tomorrow afternoon, we can meet tomorrow afternoon as well, like we did last week on campus.
Was that at 4?
You want to do 4? How does 4 work?
Yeah, if that's fine.
Yeah, 4 o'clock. Okay. Yeah, we can totally do anytime after 12 is okay. As long as I've got my virtual office hours from 10:30 to 12. Anytime after 12, we can totally meet on campus. But I just want to pin down a time so that I can post it on an announcement so that other students can come as well if they can make it.
I can come by 4:30.
By 4:30? Okay.
The kids get off camp at 4, so I just have to pick them up and bring them home.
You want to do 5 like we did last time?
Yes, perfect.
5 is fine.
Okay, 5. That way that gives you time and you don't have to rush. And you can actually say hi to your kids.
Just throw them out of the car.
How well their day went. All right, so let's shoot
more important.
I know, right? Statistics is more important for the next 3 weeks.
For the next 3 weeks.
Yes. Oh my God.
No, kids are more important. This is not.
My new baby.
All right, so 5 o'clock tomorrow. I'll post an announcement, and great. I'll stop the recording. Hopefully, this has continued to record.
Oh, it says, I think it's still recording. I hope.
Yeah, is it?
Okay. Well, yeah, it says like the little red dot, and then it's like flat.
Oh, there it is. Yep, I see it. Okay. All right, I'm going to stop the recording. Whoops. Maybe if I stop share. There we go.
It's still recording.